indicates here the principle working behind this is very simple. Some of the materials, when they are exposed to the UV light, what happens? They'll be cured, they'll be solidified. So this principle will be extended to the stereolithographic systems in order to create the 3D model of the object. And in its simplest form, it will be having the computers. The computer will be having the STL format of the model which you have created by using the CAD software. And in turn, this particular platform, elevated platform it is called, this platform on which we are going to create the model. That will be having the NC drive systems, servo controlled NC drive systems, so that each and every movement can be controlled along the X direction, Y direction, and Z direction, so that we can able to create the required model out of it. And then the thickness of the layer which we are going to make that this settling in this liquid will be totally by means of a power supply to this UV lighting technique. And by using this, what happens? One complete layer, once it is formed, then the second layer will be overlaid over this, third layer will be overlaid over this. So within this liquid itself, once it is passed to this UV lighting, what happens? It will be solidified and we will be getting the required model out of it. This is what the principle is called as photopolymerization method. And very important technique, please try to remember. With a neat sketch, explain the photopolymerization process or stereolithography process or the SLS method. Okay, all these are same. What are the advantages of this? We can able to build a complicated model, which is not possible to do by any conventional method. And the surface quality will be very good because the layer formed, the solidified layer formed will be controlled by means of a UV light power systems. Okay, and a very good resolution will be there and a clear model we can able to get. And application where all you can use them, in the functional models wherein the limit fits and tolerance has to be controlled, therein we are going to use them for the functional models, dynamic linkages and all. Okay, robot manipulators like that. And in some of the delicate manufacturing of the medical models, you can use them. Okay, and in some kind of vacuum casting tools and all, we can just do them because the vacuum casting, it is just the vacuum casting is what very simple example is that the plastic containers will be vacuum casting. Okay, vacuum casting. Okay. And just like a balloon, it will be blown and it is made to receive the shape. Okay, and some of the fine features with high quality resolution visualization models therein we can use them. So in total, the accuracy of the model will be very good. For all the physical models, you can use them. Okay, and surface finish will be to the higher order. Okay, these are the important. And fuse deposition modeling. What is this fuse deposition modeling? So before I get into that, I can show you fuse deposition modeling. It is just as good as, or just it is our 3D printer. It is a 3D printer, and the roll which will be available in the solid form. Okay, polyimide filament, and it may be up to 1.75 mm diameter. Even lower thickness also may be available, and it will be controlled by means of a servo controlled rollers, and the head will be consist of a heater. In the heater, we are going to melt it to the required temperature, and the semi molten, that is melted filament, will be made to flow through this nozzle, which will be having 0.4 mm diameter. Okay, so this molten metal will be made to flow over this, and once it is fallen onto the platform, it will be solidified, and over this solidified another layer will be laid down like that. So layer by layer we are going to construct the model. We achieve the 3D model of the object. It is useful for the solid materials. The solid materials may be available in the form of a filament. It may be available in the form of a sheet. It may be available in the form of a fillet. Okay, or a endless roller. All these maybe different forms available. Here I have shown one of the very simplest method or simplest form. This is what the discussion, and what are the advantages of using this. As compared to the other model, this will be tougher in nature and can be very much durable. And the thickness of the wall created will be very good. And this also can be used for the functional testing. The parts are not for us. The parts are not for us. Okay. And it is friendly in nature. We can use them in the office as well at home, and available at cheapest, and accurate prototyping can be get, and it will be durable for a long time. And it will be very much suitable for the structural construction and smooth part construction to a higher accurate level. Okay. What are its limitations? Limitations are the parts are having the sharpness. It is not one of the good holding point. I think we are going to anyhow. We are going to give the filleting for the model in the modeling stage, and it will be converted in a steel format. Even though we say the sharp models will be created. Okay, no problem. It is very difficult to produce the miniature models, because if you are going to create the miniature models, it will not be receiving the required shape, and it will be very slow process too as compared to the others. These are the limitations. And applications, we can go for the any prototype models and medical applications, and high resolution quality models we can get. These are the applications. And powder sintered technique, powder sintered bed centering, it is called as SLS. Okay, SLS. And here the SLS system, you can see this very in its simplest form. In its simplest form, which will be having the powder. The powder will be put into a container, and a particular middle portion of this container will be having a table, which the table can be governed to move along the z direction to the required length with respect to the time. It is totally time related matter. Okay, and as earlier we did here also, the 3D model of the object will be created, and the model will be converted into a steel format. This SL format, the information will be sent fed into this one. And once the laser is made to fall, the laser will be deflected based on the requirement by mirror. And once a particular location is the laser light is falling onto a particular location, what happens? It will be sintered. Sintered means the sense it will be solidified. So like that, to the required shape, the model can be obtained by automatic movement of the reflection above the mirror. Another one, it will be totally controlled in nitrogen gas. The nitrogen gas will be used to whole container will be having, it is called nitrogen chamber. The nitrogen chamber will be used. This is one important thing what I wanted to share. And its advantage. So wide range of materials can be used, because only the powder, it may be ceramics or metal or non-metallic, whatever it is, that can be a powder, and which will be having the affinity towards the UV light. All those materials can be melted here. And here the post curing is not required. You can see that in other cases are done the curing. That means the roll of the wire which will be preheated. In other case, it is not required here. Okay, the localized UV light movement will itself will be curing. That means it will be sintering. Okay, and infused powder act as a support. That means while it is fusing, the bottom layer will be clogged with this. That means the bottom layer and the top layers will be assumed to be a single one while it is fusing. Okay, and the support material which you are going to use them as a support can be easily removed. Okay, it can be easily removed. These are some of the things. And what are the limitations? Limitations, applications, not limitations. The applications we can use for any of the mechanical functional models. And for rapid tooling application where it required very special type of tools. Okay, based on the design and requirement, it is not possible to process in the normal conventional method of machining. We can use this method. Okay, and the sub tooling, no tools are required, and production rate also will be very good. Okay, this is about the SLS. And sheet lamination method. The sheet lamination method already we have discussed the sheet lamination method. The endless sheet, which will be cut down into a required cross section. Maybe it is a metallic or non-metallic, and maybe it is a plastic or a composite. Okay, all this can be cut down to the required shape, and they are molded one over the other by keeping one over the other, and the layers will be forming the 3D world of it. Okay, this is happening. And how this will be done? The advantages, it will be very lesser cost, and no chemical reaction, no chemical changes are required. And once after completing this layering, what happens is the assemblies to be good. And the speed of this LOM type will be very faster as compared to the other techniques, and it will be lesser expensive. It will be less expensive. Okay, expensive. It is not compared with the more expensive. And what are the limitations? The hollow parts cannot be generated, and a large amount of scrap will be generated because the neighboring drops also will have the possibility they will be sintered. Okay. And some kind of a drop of molten metal will be always clogged with the surface that has to be clearly removed. And it appears to be just like a sandblasting technique. We are going to create some models. So some kind of rough surface will be produced in the similar way here. The rough surface will be produced by using this LOM technique. And the part removal will be slightly difficult because the metals will be fused together, and part removal will be slightly difficult as compared to the other techniques. Applications where you can use this silicon molding, secondary casting and tooling, injection molding, the sand casting and investment casting. Okay, in some of the architecture work and furnitures. Okay, and medical models and dental designs, and some of the scaled models we can use by using this technique. We can use laminated object techniques. So this is about different techniques I wanted to discuss. Please try to remember photopolymerization method, that is stereolithography, and another one is the fused deposition model, FDM. It's quite good as your 3D model only. And another one is the last one, powder bed sintering.